Okay, the sum of an arithmetic series. I always call it arithmetic. I call it that because it has to do with adding either positive or negative values. So you can call it adding or subtracting, but really you're adding a positive or you're adding a negative value. But anyways, an arithmetic series. We have two formulas. Okay, so the S stands for the sum, and the N lets you know how many terms. Because technically, a series could be infinite. It could go on forever, and then that's a bit different for calculating. But in this one, it's like a series that has a set number of terms in it. So the very first formula is stated here, and the second one's here. So this is what we're going to do. We're going to make our own, and then we're going to test them to see if these things work, okay? So, you want to come up with one? What would you like our first number to be?
50.
Series 1. 50. Nice. What would our common difference be?
4.
4? Positive or negative?
Positive.
Okay, so I can add by 4. I'm okay at that. And how many terms would you like us to add to?
10.
10 terms. So we'll say go until I can say T10. I'm going to say something like that, or 10th term. So we'll do a little defining here. This here is actually considered T1, okay, which would make this T2, this T3, which really relates back to the second formula. In this formula here, we have T1, okay, in which case we know that it's 50, and then Tn. Well, n in this one is the 10th term, so we'd have to actually figure out what the 10th term is. And in this series, I've actually only written out 3. I'd have to go through the whole thing and figure out to the 10th term. So instead of doing that, let's take a look at the first formula. I mean, it's something we can do, but the problem is, what if this becomes like the 100th or the 1000th term? Then this is going to take forever, right? So let's take a look at the first one. Can we use the first formula to solve that? That's one of the things you want to decide. Is Formula 1 better or is Formula 2 better in our case? So right now, in Formula 2, we have n and we have T1, but we don't have T10 or T at n, okay? So let's try here. N, we know the numbers of terms. It's 10. A is the value of the first term, or T1. It's technically the same thing. We know it's 50. We know n, and do we know the common difference?
Yes, 4.
Yeah, we said it was 4. So perfect. We got everything we need for that formula. We know the common difference is to add 4 every time. So check. We're going to use that formula to start, okay? So let's shrink it. Put in that little corner there, and then we'll write out our formula. So S, and then we're going to say 10. The sum of the 10 terms in this is equal to, we know that n is the number 10, so I'm referring to that little formula there on the side, okay? The value of 2 times the very first term, which is 50. So 2 times 50, plus n minus 1, which is 10, subtract 1, all multiplied by the common difference of 4. Okay, and that's like the numerator, you'd say, of this fraction here, and all of that is divided by 2. So we just got to do some calculating now. This is actually relatively simple bed math. Work inside those brackets. Okay, we have 2 times 50.
100.
Yeah, that's simple. And then we know 10 minus 1
9.
times 4.
36.
Great. Nice and fast. Okay. What is 100 plus 36?
136.
Times 10.
Times 10 is 136. No.
136 with...
2 zeros. Or it's multiplied, so 1 0.
Yes, 1 0. Good. Perfect. Or 1036, okay? And then if we divide it by 2, I'll do this really quickly. It is going to be a 6, an 8, and a 0. So 680. So the sum of this series is 680. Okay, that's nice. So the first formula we think checks out, but let's actually get far enough into this that we figure out the information for Formula 2 and test it to see if we get the same answer, okay? Because we can make up any series we want, but what we're going to do is kind of do a little bit of a comparison. So if can I do this? I can. Oh, I'm getting better at this. I'm going to zoom back in. So at our third term, let's continue. Next one would be 62, 66, 70, 74, 78. Am I even close right now? T4, T5, T6, 7, T8, T9, T10. We need 2 more, 82 and 86. Okay, zoom back out. Okay, so if we were to use formula number 2, okay, we'll do it in yellow, our T at n is 86 in this case. So a bit of a simpler formula. S at 10 is equal to 10 multiplied by T1, which is the same as the A value, is 50 in our case, okay, plus the last value in our series, is 86. And all of that is divided by 2, okay? So let's take a look. 50 plus 86.
136.
Great, and I'm going to stop right there. Do you see any relationship between the two of these?
Yes.
Yeah. Right here. Though we kind of skipped a step, we know 100 plus 36 is 136, and that's the value here. And we know if we carry out the rest of the operations, we're there, right? So the only real difference between these two formulas is what type of information you've been given. So we know we need a minimum bit of information. We either need to know the last and the first term and how many terms there are in total, or we need to know, again, how many terms in total. So that's an imperative. We've got to be able to figure that out. They may not state it in the question, but we may be able to do a little math to figure out what it is. So we need to know the number of terms, and we either need to know the first term and the common difference, or we need to know the first term, so you got to know the first term again for both, and what the last term is. And as long as you have any combinations of those, you can figure out essentially what this is. Okay? All right.